So, in my winter quarter status update, I proposed an algorithm for breaking up code into exercises for scaffolded exercises. While some of the logic may still change, the general ideas stand, so I thought it would be helpful to make a video explaining what I explained during my status update so that there's context that's easily available in preparation for any technical discussions or decisions that are to come for scaffolded exercises. So the interface is well explained for scaffolded exercises, is well explained in the project's SRC submission, as well as the practical research canvas. So I don't want to spend too much time on the interface itself here, but I think it would be helpful to motivate the algorithm if I explain how it relates to my interface, which is well explained. So the system needs to do two things to support my interface. First of all, there needs to be some sort of value tracking, so that you can see the value of the program variables as the page changes in response to user interaction. And the second thing is that I need a way to break down code into smaller components, which is, this is an example of a component right here. And then I need to sequence those components, or chunks as I call them, in order to help an intermediate developer understand different components of the code and how they relate. So the algorithm that I'm going to explain in this video is for the work that I'm doing on this second thing. So this code breakdown and exercise ordering piece of the system. So before I get into explaining kind of how the algorithm works, just some vocab or context. So the algorithm considers a program as a sum of smaller components, which I'm calling nodes. So a smaller component might be a variable definition, it might be an assignment expression or a function call. So it's anything that isn't the whole thing. And it can be broken down to different levels of granularity. And you can think about that like how an abstract syntax tree might break down a program so that a single node contains many subnodes. And the granularity of the node just depends kind of where you're looking in the tree. So anything that isn't the whole thing is a node. And that'll be important later because I'm going to discuss kind of how we use the idea of nodes to break down different exercises, or to break down the code into exercises, excuse me. So the algorithm centers on nodes that include DOM interactions or modifications. And each DOM object included in the program can have three kinds of related nodes. So let's say that there is a DOM object that's just like a red square div on a page. So then it can have things that are related to it, or different nodes that are related to it, that have to do with its setup, with its modification, and with its use. And I'll kind of explain those a little more in depth now, and then it'll make it a lot clearer when I explain how the algorithm actually works. So also, just for context on why we're centering on DOM interactions, it's because we're trying to rely on learners' visual observations to help them build intuition about program logic or functionality. And I also discussed that in my SRC paper a little more in depth, kind of the learning value of that approach. But that's kind of why this is also important in the system, because we're just building off of the interface that presupposes that we're focusing on these visual interactions. So let's say that we have this red div on a page. An initializer node related to this DOM object, this red node or red square DOM object div, would be if there are properties for that red div that are set in the HTML. So for example, let's say that its position from the top and left corner of a screen were set in the JavaScript, then that would be whatever code that was doing that would be an initializer node for the given red div DOM object. Then each DOM object can also have a related modifier node or multiple modifier nodes. And that's any code that is changing the values of the DOM object. So that's if a function or some node updates the background color of the div, for example, as a user drags their mouse or scrolls the page, then that'd be an example of a modifier node. And then finally, a user node, which again, a DOM object can have 0, 1, or many user nodes, is something that uses information about the DOM object but doesn't change it. So an example of that might be, I want to know where the div, that red div is, its top left positioning matters to me so that I can position the next item on the page. So I'm using the div to find, or the DOM object to find information about the div, but I'm not actually changing it. So me looking up information about that div won't change its values. So those are the three kinds of related nodes. That'll be important in a second. But first, so the first exercise selection is pretty simple. It's straightforward. So if you have someone interacting with a screen, then the first exercise that you show them is the most recently executed modifier node. So going back here, the modifier node is the thing that changes an already existing DOM object on the page. So, and then going forward, so the first exercise will be that most recent modification. And then the DOM object or objects modified by this node is what we're going to call our reference object. And for simplicity's sake, we're going to start by assuming that there's only one DOM object that's included in this exercise. In a few slides, I'll address the case when there's multiple DOM objects introduced in a single node. We'll get there in a second. So let's just say the first node, or the first exercise, excuse me, is the most recently executed modifier node. And most recent means most recent in the call stack. Okay, so we have our first exercise. It's that most recently executed modifier node. The DOM object within that modifier node is what we're going to call our reference. So how do we pick the second exercise? Okay, so this looks a little insane, but we're going to go through it slowly. So each time that we pick a new exercise, we're going to, after the first exercise, we're going to use kind of this flow chart. So if the reference is initialized in JavaScript, so if there is an initializer node in the JavaScript, that's going to be our next exercise. There it is. If not, or if we've actually already served up that initializer node for the reference as an exercise, then it's, if that node has been visited, right? We've done an exercise on it already, so we're going to move on. That's not going to be the second thing we pick. So that's no. So then we're going to see, is the reference modified? And that is there another instance that's different than the code that we're already looking at, or that we looked at in the previous exercise, or in any previous exercise, that changes the values of the DOM object? If yes, then there could be more than one modification. And if that's the case, then we're just going to pick the most recent modifier node that includes the reference. So let's say there are three things that modify this DOM object that are separate from anything we've gone over before, so that are quote unquote unvisited. Then we're going to visit the most recent one of those. And most recent, again, meaning most recently executed in the call stack. So let's say that either we've already visited all of these modifier nodes, or there is no other place where it's modified. Then we're going to check if the reference is used. So that is, again, when you're checking or utilizing the values or properties of the DOM object, but you're not actually changing the DOM object itself. And if that is the case, we'll go to the most recent user node that includes the reference. Once again, it has to be unvisited. And if there's only one, then we pick that. And then if there's multiple, we go to the most recent unvisited one. Let's say that there's not, so that we've gotten to the end of kind of this decision tree here. So then the next thing that we're going to do is we're going back basically to the exercise one selection logic. We're going back and we're finding the next most recently executed modifier node, even if it doesn't have to do with our current reference. So that could be the case where there's an entire another DOM object on screen, and that's also been modified recently, let's say, but it doesn't really have to do with, or it isn't present in any of these, or maybe it is, but whatever. There's a case where it could be present in any of these. We're going to get to that in a second. It's not whatever, but 1 second. So we'll go back basically to the exercise one selection logic. We'll do the most recently executed modifier node that is unvisited. So an exercise has not been done on it yet. Okay, so this is kind of how it will work as long as there's just one reference object. But once more than one reference object is introduced, it gets a little bit more confusing, right? Because now we have to contend, we have to decide which exercise should be served up based on not only kind of recency or type of node that it is, if it's a user or a modifier or initializer node, but also based on which DOM object it's related to. So how do we choose that? The current logic goes like this. So if we have just one extra, let's say in this case, now instead of one, we have two. So one extra DOM object that is being referred to. And And this logic should be able, that I'm about to explain, should be able to work with an arbitrary number of DOM objects, but just with more layers of this kind of checking. So there'll be kind of more branches in the decision tree. But for simplicity, we'll just discuss the case where there are two DOM objects. So now the original reference that, let's say that red div that we've been talking about, that's the is what we're going to call the original reference. That's that. And the new reference is the DOM object that was introduced in a previous exercise. So there was a question during my status update of like, okay, how does this happen? Like, how could you get a new reference? And that's the case where in the same node, code node, there is more than one DOM object that is introduced or utilized or referenced. So if the new reference, that new DOM object that it has been most recently introduced, is initialized in the JavaScript, okay, then the next exercise is going to be the initializer node for that new reference. If not, we're going to check, okay, is the new reference modified ever? And let's say that it is. So maybe it's modified once, maybe it's modified, X times, it doesn't matter. So if the answer is yes, what we also need to do is check if the original reference is modified. In the case that both of them have been modified and have unvisited modifier nodes, then the next exercise that we choose is the most recently executed reference modifier node. So between all the nodes that modified both the original and the new reference, we're going to pick the one that executed most recently in the call stack. If not, our decision is easy. So we get to our next exercise is just the most recent modifier node that includes the new reference. So no matter what, we're always preferring modifier nodes. And that is kind of the thing that drives here in the case where only one thing was modified. So then like why this is important is, for example, let's say the new reference was modified. The original reference was not modified, but the original reference was used. Then in that case, we are going to still pick the modification node. Okay, but so let's say that the new reference wasn't modified. So then if the original reference is modified, then the next exercise will be that most recent node that includes or modifies that original reference. But if both the new reference and the original reference were not modified, then we're going to check the use nodes that are related to both of those. So basically, this is the same decision tree for that we just saw for new ref, original ref modification, but just for use. And we're doing the same checking, but again, now we're just thinking about uses, not modifications. If they are both modified, pick the most recently executed ref, or sorry, both used. If they were both used, pick the most recently executed ref user node, either the original ref or the new ref, doesn't matter, whichever one happened most recently. Otherwise, if only the new reference was used, then pick the most recent user node. Excuse me, this should be user node. That includes the new reference. Otherwise, if the new reference was not used, but the original reference was used, we'll serve up the user node for the exercise of that original reference. And again, similar to the exercise 2 selection logic that we just went over a couple slides ago here, this one, if neither reference has been used nor modified, then our next exercise, so neither reference is used, neither reference is modified, then we're going back against that exercise 1 selection logic. So the most recently executed unvisited modifier node. So that was really quick, but I hope this was helpful just for getting an idea of how the algorithm would run for exercise selection and breakdown. Cool.